Hi, I'm glad you came today. We're moving on in our unit of scientific measurement to talk about how do you convert between English and metric units. Now, they don't have to teach this in the rest of the world because other people don't have a system of units that they're familiar with that's not metric. But in America, so I'll start calling them American units, we have to convert between the sizes of the units we're used to the sizes of the metric units. So the first two essential questions are just the opposite of one another. The first one, how can I convert from a metric unit, such as liter, to a American unit, such as gallons? Or vice versa, how can I convert from the American unit of gallons to the metric unit of liters? All right, and the third one is the most important. It is, why is a conversion factor called a ratio of equal measurements? These are the things that we will be learning today. All right, so the first thing I'm going to start with is a video by Tyler DeWitt. He's my favorite YouTube video maker, so you'll see quite a bit of him. What I find is that he explains things very well. And you know how I'm a maniac for explaining things. So I already have him up here, and let me just move my box around, or I can't move him on the page, so just a second. All right, so understanding conversion factors.
This is a problem. I want to try to address it in this video. In this video, I want to talk about how to understand conversion factors, okay? I want to talk about how to understand how they work and what's really going on when you use them. I want to talk about how to understand the math, and most importantly, how to look at a unit conversion problem and think through it so that you can then look at the answer you get at the end and decide whether it makes sense or not. We're going to talk about this thought process by working through this problem here, but we're not going to use conversion factors right away. Here we want to find out how many inches are in 4 feet. In order to do this, we'll need to know a relationship that ties inches with feet. You probably already know that there are 12 inches in 1 foot. And I've drawn this out so you can kind of have a look at it visually. Here's 1 foot, and here are the 12 inches. Now, how do we go from inches to feet? Let's just think about it, okay? If you have 1 foot, you're going to have 12 inches, okay? If you have 2 feet, you're going to have 24 inches. What am I doing here with the math? What I'm doing is I'm doing multiplication, okay? I'm doing 1 times 12 equals 12. I'm doing 2 times 12 equals 24. This is the number of feet, this is the number of inches. So, to figure out how many inches are in 4 feet, I'll just do 4 feet times 12 inches, because I know that there are 12 inches in each foot, and I'm going to get 48 inches for my answer. 4 times 12. How would I do this with conversion factors? Okay? I'd set up a problem that looks like this. I'd have my 4 feet here, and then I have 12 inches over 1 foot so that the feet cancel out. Look at the math that's going on here, though. I'm just doing 4 times 12 and then dividing by 1, but the division by 1, it doesn't change anything here. So the only thing that's really important is that I'm doing 4 times 12. And that is exactly the same as what I do here when I just kind of think through the problem. Let's look at a similar one. Here, we're going from inches to feet. How many feet are in 96 inches? Let's think about this the same way, okay? If I had 12 inches, how many feet would that be? It would be 1 foot because there are 12 inches in a foot, okay? If I had 24 inches, I'd have 2 feet. I have 36, I'd have 3 feet. The math I'm doing in this case is division, okay? I'm taking my 12 inches and I'm dividing it by 12 to get 1. 24 divided by 12 equals 2. 36 divided by 12 equals 3. So you have inches, you want to get feet, you divide by 12. So I got 96 inches here, and I'll divide by 12, and that will give me 8 feet. Oh, look at that. I wrote 8 foot. It's like I can't even speak English. 8 feet. Okay, anyway. Now, to do this problem with a conversion factor, I'd set it up like this. 96 times 1 divided by 12. The inches cancel out. And I do 96 times 1, which doesn't change 96. It's still 96 divided by 12. So I'm really just doing 96 divided by 12, which is what I have up here. So there are two important things to take away from this. Okay, the first is, if you have a number like 12 on the top of a conversion factor, it's the same as just doing multiplication here. Okay, I'm just doing, because there are 12 inches in each foot, I have 4 feet, so I just do 4 times 12 and I get that. If a number like 12 is on the bottom of a conversion factor, it's just division. Okay, for all these 96 inches, for every 12 inches there, I have 1 foot. So I'm just doing 96 divided by 12 gives me 8. The other really important message here is that if you understand what's going on, you're able to look at the answer you get and decide whether it makes sense. Okay, here we're going from feet to inches. Okay, their inches are small, so there are a lot of inches in each foot. That means that when we're going from feet to inches, if we start with a small amount of feet, we should get a bigger number of inches. And that's exactly what's going on here, because there are a lot of inches in each foot. On the other hand, when we're starting with inches and going to feet, we should have a lot fewer feet than we had inches. And so here we go from a lot of inches to just a few feet, and that makes sense, so that I know that I set things up right and I'm on the right track. Always keep this thought process in mind whenever you're working through a problem with unit conversions, okay? Here I'm going from miles to kilometers. I've drawn out a little diagram here. Obviously this is to scale. It's much smaller, but here's 1 mile, and this is how big a kilometer would be. Okay, so I know that there are this many kilometers in 1 mile. Kilometers are smaller than a mile. So 1 mile has this many kilometers. I want to know how many kilometers are in 2 miles. I take this number and I multiply it by 2, and I get this number of kilometers. How many kilometers are in 3 miles? I take this number, I multiply it by 3. So we're doing multiplication here. So it makes sense that when we look carefully at what's going on with a conversion factor, we're doing 14 miles times this, the number of kilometers in a mile, to get the final answer. Now, does it make sense? What if this were a problem on your test? Could you figure out whether it made sense? Well, kilometers, as you can see, are smaller than miles. And there are more than 1 kilometer in 1 mile. So that means that we should be getting more kilometers than miles. Start with 14 miles and end up with 23 kilometers, and that makes sense. Here we're going from pounds to kilograms. And there are 2.2 pounds, there they are, that equal 1 kilogram. So if I have 2.2 pounds, I have 1 kilogram. I can divide that by 2.2 just to show that I get 1 kilogram. Okay? If I have 4.4 pounds, I divide that by 2.2 and I get 2 kilograms. If I have 5.50 pounds and I divide it by 2.2, I get 2.5 kilograms. So to go from pounds to kilograms, I want to be dividing. Look at the conversion factor. That is exactly what's going on here. I'm starting with 53.5 pounds times 1, which doesn't change anything, and I'm dividing by 2.2, just like I am here. Okay, does the answer make sense? Well, here I have 2.2 pounds, and I have 1 kilogram. So there are fewer kilograms than pounds in the same weight. So when I'm starting with 53.5 pounds, I expect to get a smaller number of kilograms, and there I have 24.3. So I probably set things up correctly, and my final answer makes sense here. Now, a lot of the times you're going to run into questions where you have to put a bunch of conversion factors together. But a large problem like this, you can still break it into smaller sections that then you can understand individually. Okay? So you can think about just this first part as being 3.5 days times 24 hours gives you an answer in hours. Okay, that's this part. And then you take this and you can pull it down, and now we use 84 hours and multiply it by this conversion factor and then get our final answer. So even for a large thing like this, you can take it piece by piece if you want to make sure that each step makes sense. So anyway, whenever you're solving these conversion factor problems, always try to make sure that you really understand what's going on. Ask yourself, am I multiplying here or am I dividing here? Does it make sense that I'm doing that? And then finally, look at the answer that you end up with and ask, is it bigger or smaller than the number that I started with? And does that make sense? And that way, you won't just be a unit conversion robot, you'll actually understand what you're doing. And that's the most important thing to do.
Click the honey button.
So, what he just showed you to do, the name of this could have been, do I multiply or do I divide? Because that is the biggest question when you're doing problems. So we do a lot of math problems, and students always ask, do I multiply or do I divide? So he was trying to show you that the conversion factor helps you to figure that out. But he was also showing you, even more importantly, that you can think through these things and don't have to rely on just mechanical use of conversion factors. All right, so let's talk about conversion factors. Let me get this back down to where it needs to be. All right. Here we go. All right. I'll make this as big as possible. I know you have this too, so it's not a crisis. So, conversion factors. Now, what I want to do, first of all, is show you this one down here. All right, so I made a conversion factor, or this in this assignment. So, some possible ones. These are all the American ones over here on this side, and these are all the metric over here on the right. All right, so there's 1 inch and 2.54 centimeters. All right, this one is how many quarts, linking quarts and liters. This links the number of yards in a meter, miles in a kilometer, inches in a meter, pounds and grams, pounds and kilograms, and ounces to grams. All right, so here's a list of them that we will use in our problem solving. All right, so what I was just showing you were the conversion factors. All right, let me just make this smaller now to fit in our box. All right, conversion factors between units require the use of a special type of ratio. So a conversion factor is a ratio known as a conversion factor. So they're really fractions where the numerator and the denominator, even though they're expressed in different units, have the same quantity. They're the same amount of stuff. For example, 12 inches equals 1 foot. It's the same amount of length. 12 inches is the same amount of length as 1 foot. The two terms are equal to one another even though the numbers are different. They're equal because they represent the same distance, right? The same length. So here is the way we would look at them. 1 inch, 1 foot over 12 inches. They are the same quantity, correct? Or we could write that conversion factor flipped as 12 inches over 1 foot. So what we do with a conversion factor is take it in one form or the other. A foot is the same as 12 inches. 12 inches is the same as a foot. We can write a conversion factor either of these ways. Why is that? Well, they're the same quantity. So this length is equal to this length. This length is equal to this length. So a ratio is a fraction, and aren't both these ratios of equal amounts of length? The numerator and the denominator are equal amounts of length, whether expressed like this with foot on the top, or whether expressed like this with inches on the top. All right? So, which variation of the conversion factor that you use will depend, it's determined by the units that you are converting. All right? So if you are converting from inches to feet, that is, you know the inches, but you don't know the feet, then you would use the conversion factor on the left, this guy. All right, then of course they're going to say what happens. So we'll look at a calculation. So let's go down. Rather than do it in words, I'll show you. So let's say we start with 48 inches and we want to convert it to feet. All right, so we write out our 48 inches and we know at the end we're going to have some number of feet. All right, now we set up the conversion factor. We could put 12 inches over 1 foot as a conversion factor, or we could put 1 foot over 12 inches. And the reason we're doing it this way is because this inches here will cancel out. Inches in the numerator will cancel out an inches in the denominator. Inch over inch equals 1. All right, so what this means then is we will do this. And the only unit left is foot, and it's in the numerator, so there it is. Changing it to the plural now. So what's really weird about this is the calculations show the units. Who's ever heard of that, right? Well, we do that in science all the time because remember, our numbers are always measurements made by tools. So we're always using units, so we just do math with them. Very cool. I always thought that was very cool as a student. I hope you would too. Okay, now the units of inches cancel, which leaves the unit. Now, we wanted to go from inches to feet, and so when we're left with foot right here, that means we're going to get our answer in feet. And then the point he was making is, since there's 12 inches in a foot, if we have 48 inches, we won't have 48 feet. We'll have many less feet. Since an inch is so tiny, there would be many of them in the same length. All right? Now look what would happen if we had used the conversion factor the other way. We would have had 48 times 12 equals 576, and the inches in the numerator times the inches, or inches squared, whoever heard of that, over 1 foot. So this unit is not a foot. We were trying to change inches to foot. Well, what on earth is that unit? So when you get a weird unit like that, you know you multiplied and you maybe should have divided. All right? So not only is the number ridiculous, we shouldn't have more feet than we do inches. Ridiculous. The unit is weird. So conversion factors are a very convenient way to convert, but you just have to use them correctly. You have to know whether you want to put 1 foot over 12 inches or 12 inches over 1 foot. Well, how do you figure that out? You want the inches to cancel, so you know the 12 inches. The number has to go with the unit, has to be down here in the bottom to cancel the inches in the top. All right, the numerator is the number on the top, the denominator, the number on the bottom. So then inches will cancel and we'll get the answer in feet. This is particularly useful when you are less familiar with the kinds of numbers in the calculation. And we'll see as we go on in chemistry that will be true in many cases because you're learning about these new kinds of things. But yet we're trying to figure out problems with them. So you will love these factors. Honest to goodness, I was a very advanced student at this point. And we got this challenge question on a physical chemistry test, and I could not figure out to do it. So I thought, well, at least I can sit here and fiddle with units and figure out how I could get the answer. And I got it right. And then when I saw what the answer was, I knew what the essay part of it meant. All right, so this is very useful. It's very, very useful. All right, now, the question we're coming to again is, why is a conversion factor called a ratio of equal measurements? Well, it's because the amount of length in the numerator equals the amount of length in the denominator, or volume. The amount of volume in the numerator equals the amount of volume, same amount in the denominator. So that's what we'll be thinking. So make the following conversions and then submit it to me for grading. Actually, I'll figure out another way for us to do this. So we'll work on it. So you have a calculator on your computer. So search for the calculator. I'm going to go over here to when I go to this page and click on all apps under C, I found calculator. Then I wanted to do more than pin it to the start. I wanted to pin it on the taskbar. All right, because we'll be using calculators a lot, so you don't want to have to do this every time. Either pin it to start or pin it to the taskbar. That's where I have mine. All right. Now, answer the problems below. Remember, cross out the units to discover the identity of the unit that goes with the number in the answer. All right, so let's go down here and do this first one. Let me make it gigantic. All right. Now, we have 3.26 quarts, and we want to convert to liters. All right, convert. This is what the problem really is. 3.26 quarts to liter. All right. So it turns out that 1 liter contains 1.06 quarts. And of course, we could also say that 1.06 quarts is the same as 1 liter. All right, both of these are true for this problem. So now we look and we decide we're starting with quarts. So if I start with quarts, I know I want to have quarts in the denominator because do you see how I'm going to be able to cancel out quarts? Because quart over quart equals 1. So that's how I know I'm going to use this form of this form of the conversion factor to cross out quarts. All right, so it goes in the problem. So now with your calculator, I want you to see that this shows us that we are going to take 3.26 and divide it by 1.06. Because when you multiply something by 1, it's the same number, isn't it? So this shows us that this is a division problem. 3.26 divided by 1.06, and the unit that is left is liter. All right, so do that calculation now on your calculator. All right, I'll pull up my calculator if I can find it here. There it is. All right, so pull up your calculator. While people do the problem, I'll remind you how to get there. So to pull up a calculator, you go down over here at the bottom left of your screen on the 4 squares. All right, that opens up all of our apps. So I'm just going to go to all apps, and they'll be in alphabetical order, and calculator is at the top of the C's. So I'm going to right click on it, and I want it to pin it to start. All right, and then when I do that, let me show you what we have. We have now put calculator right up here. Now that may be good enough for you, but I would like to actually pin it on the taskbar. All right, so that's what I'm going to do, because when we need a calculator, we want it now. I don't want to have to go to an extra step. All right, so I have it on my taskbar. So when you take 1 and you divide it by 1.06, we should get a number less than 1, shouldn't we? And what do we get? 1 divided by 1.06 equals 0.943. So 0.9. So it's a number less than 1. 0.943, and we know liters is the answer. Now you're probably saying, well, how come you don't write 94339622641500943? Well, because in measured numbers like this, these are all measured numbers. What we do is notice how many numbers there are here, 3. And there's 3 numbers in 1.06, and there's 3 in 1.00. So I'm putting an answer here in liters that has 3 numbers too. So it looks like the other measured numbers. Yeah, plus who wants to write all those numbers from the calculator? So the only unit left is liter, and it's in the numerator. So liter is the answer. So I want you to now go ahead. Now the idea is not to do them rapidly, but it's to understand them, because we're going to be doing things like this over and over again. And once again, I'm wanting you to get fluent, more fluent doing these than I am in Spanish. All right, we have to have a bigger goal than that. All right, so I want you to do these 10 problems. So work on your own now. Go.